Yes. Now you will survive.
This is nonsense! I'm going!
Hello there, boys and girls. My name is Captain Jack Sparrow. Today we're going to be teaching you a little bit about physics. As you saw in the last video, I jumped off the cliff and fell. Did I fall to my death? We're about to find out.
Okay, so the first equation we had to find as a basis for the rest of our equations was height. And we used that by finding the initial velocity times time, which we estimated to be about 4 seconds, plus 1/2 times gravity, which is 9.8, and then times the time squared. So we added and multiplied all that up and ended up getting 78.4 meters, which if you look over here, you can see that's how high he fell.
Okay, next we had to find the velocity, which equals the square root of 2 times g times h. We plugged in the information we had, and we used the square root of 2 times 9.8 meters per second squared times 78.4 meters, which we found in the first equation. Once we multiply that out, we get the square root of 1,536.64. And once you use the square root of that, you get plus or minus 39.2 meters per second. And we use negative 39.2 because we are defining up to be this direction. And since he's falling down, we have to use the negative.
Next we had to find momentum. To do that, we used mass times final velocity subtract mass times initial velocity. Based off the internet, his weight is estimated to be 71 kilograms. We plugged that in and timesed it by 39.2 meters per second. Then subtracted that from 71 kilograms times 0 meters per second. We ended up getting 2,783.2 subtract 0. And his final momentum was 2,783.2 kilograms times meters per second.
Okay, next we had to find force. Force equals the change in momentum over the change in time. We plugged in the information we found in prior equations, and we used the change in momentum to be 2,783.2 kilograms times meters per second divided by 4 seconds minus 0 seconds, which equals 4. After dividing those two, we get a final force of 695.8 newtons.
So next we had to convert newtons to g-force, and we did that by finding momentum over the weight times gravity. We found the momentum in the couple previous equations to be 2,783.2 newtons, and then we divide that by 71 kilograms, which was his weight, and times it by 9.8 meters per second squared, and we ended up getting 2,783.2 newtons over 695.8, and we ended up getting 4 Gs. And this basically is saying that he wouldn't die, but he would have several injuries, usually 5 to 10. The closer you get to 10, the more serious injury. So just based off of this, he should be able to be okay. But you also have to take into consideration the fall and where it took place. There was a waterfall, and so there were also several rocks at the bottom of the water. So that could change the amount of injuries that he had. When he fell from this height and fell feet first instead of head first, it pushed him down into the water faster, but you also have to take into consideration all the rocks at the bottom. So depending on where he fell and the height, the depth of the water. So it wasn't very deep at all. So I would say he would have serious injuries, including a lot of spinal cord injuries. Alright, so here we have our real life Captain Jack Sparrow, and we are trying to show the scene where he is running to the edge of the cliff, and he looks down at how high he is up, and it's 78.4 meters, and he looks down at the water, and it's right by a waterfall, so there are rocks at the bottom. So he's kind of freaking out, but there are some like evil dudes behind him chasing him, so he's trying to weigh his options. So here he goes, and he decides, I'm going to take the chance and jump into the water. And as you can see, he doesn't look very happy right now. We calculated 4 Gs is usually enough to have some injuries, but not actually really hurt a person. But I think we came to the conclusion that since there are rocks at the bottom and it's very shallow water, that I doubt that he would survive, or he would have very, very serious injuries.